when our type checker encounters a let type, it needs to store several pieces of information in the type environment. First is the type name D. Second is the variant names, x1 and x2 here. And third are the argument types, tau1 and tau2. We'll use this notation here to say that the defined type D is equal to the joint sum of these two variants, x1, which takes an argument of type tau1, and x2, which takes an argument of type tau2. To implement this new thing inside the type environment, we'll extend our type bindings. We now have a tdef to go along with a let type, and this packages up everything that we've talked about above, a type name, two tags, and two argument types. One more thing we'll need to worry about as we go through type checking is which type names are bound at a given point in time. For example, this expression might be okay depending on what we fill the dot dot dots in. But the key point to raise is if we have a type fruit on the inside, that is all right because fruit can refer up to this let type fruit. Something that would not be okay is to have fun fruit by itself outside of any let type declaration. A type checker needs to catch code like this and raise an error. In order to do that, we'll need a set of rules to say when a type is valid. That's what this turnstile function is doing. First up, a defined type D is valid if the current environment includes D. Int type is always valid, Boolean type is always valid, and if arrow type is valid as long as the left-hand side and the right-hand side are also valid. We will implement b- with a new function called tvarCheck.